Okay, let's switch gears a little bit. Let's talk about complex numbers. So when we take a square root, we assume that it's a positive number. And when it's a positive number, we give it a value of, say, if a is equal to 4, then it's 2. If a is equal to 25, then it's equal to 5. For instance, it's, the opposite of x, or I guess in this case we should be using a. It's basically the opposite of a squared, in a way. Kind of the opposite, not really. I mean, they would undo each other, but you plug a number in, you get a number, but this is restricted to positive numbers, or is it? If you plug in a negative number, -1 for instance, it doesn't really work so well for real numbers, but when you have a complex number, you assign this to I, or I is equal to the square root of -1, or I squared is equal to -1. And now we can factor numbers that we didn't think were possible. Not just factor, but solve and solve negative square roots. So if we say a is equal to a plus bi, we have a real and an imaginary part, and this is what makes it complex. And then we also say that x also has a complex conjugate known as like x bar, and this is a minus bi. Now if we were to multiply these together, sometimes I guess it's also referred as x star, but if we multiply them together, a plus bi times a minus bi, a squared plus abi minus abi plus, well, not plus, minus b squared I. And this is a squared. These terms cancel, and we have minus b squared, which is -1. I mean, not p squared. This is I squared. Sorry. A squared minus -1 b squared, or just a squared plus b squared. And that's how you would factor, like if a is equal to a squared plus b squared, or you could factor these out. We can graph, like, say x is equal to 3 plus 2i. We can graph this now. We have the real and imaginary planes, axes. 1, 2, 3, 1, 2. So 3 plus 2i would be 3 on the real and 2 on the imaginary. So it'd be like right here. If we were to graph the conjugate, it would be down here. Complex numbers add together. They could be multiplied together. They could be divided. I already mentioned the complex conjugate, and how it would become like a squared plus b squared. We also have the absolute value. The absolute value of x would be the square root of a squared plus b squared, which would be, in this case, if it's 3 plus 2i, 3 squared plus 2 squared is equal to the 9 plus 4, or no, not 14, sorry. 13. To find an angle, there's an angle right here. This angle is going to be the arctangent of b over a. For our instance, it's arctan of 2 over 3, which is equal to around 0.59 radians, or 33.69 degrees. And that's about it for that's about most of the complex stuff. Sometimes we'll see e to the ix, and I'll show how to handle that in another video, but it basically becomes cosine x plus I sine of x. Anyway, thanks for watching.